The Allien System is the first to make contact with our solar system after 8 planets have been found. The Kepler-90 system is now tied with our solar system for the most planets after the discovery of an 8th planet. Similar to our solar system, Kepler-90 has gas giants orbiting farther away from its sun-like star and rocky planets close to it. None of the planets on Kepler-90, which is more than 2,000 light-years away, are thought to be habitable. The Kepler-90 star system bears a resemblance to a scale model of the solar system. Large planets are outside and small planets are inside, but everything is much closer together. Other planetary systems may hold more promise for life than Kepler-90. Kepler-90I is approximately 30% larger than Earth, and is so close to its star that its average surface temperature is thought to be greater than 800 degrees Fahrenheit, which is comparable to Mercury. Its outermost planet, Kepler-90h, orbits the star at the same distance as Earth does the Sun. In the Kepler-80 system, a 6th planet was discovered. This one, the Earth-sized Kepler-80g, and 4 of its neighbor planets form a resonant chain, which occurs when planets are trapped in a repetitive orbital dance due to mutual gravity. As a result, the system is extremely stable, similar to the 7 planets of the TRAPPIST-1. Kepler-90I, a scorching hot, rocky planet that orbits its star every 14.4 days, was discovered with Google machine learning. Machine learning is a technique for artificial intelligence that allows computers to learn. In this example, computers were trained to detect planets by examining Kepler data for instances where the telescope recorded brightness changes caused by planets outside our solar system, also known as exoplanets. Kepler looked in many directions. At any given time, we can see approximately 1/400th of the sky. The Kepler-90I and Kepler-80g planets were discovered in the original Kepler field, which we investigated for 4 years. This field is in the constellation Cygnus. We've observed larger areas of the sky for about 80 days at a time. So far, we have covered an additional 16 fields. I feel like we're constantly discovering amazing things. If a planet passes directly between a star and the observer's line of sight, it blocks a small portion of the star's light, reducing its apparent brightness. Sensitive sensors can detect the periodic decrease in brightness. The transit period and depth can be used to determine the planet's companions' orbits and sizes. Smaller planets produce smaller effects, and vice versa. A terrestrial planet in an Earth-like orbit, for example, would result in a brief decrease in star brightness lasting only a few hours. With the 2017 discovery of an 8th planet circling Kepler-90, a sun-like star 2,545 light-years from Earth, our solar system is tied for the most planets orbiting a single star. The planet was discovered using data from NASA's Kepler Space Telescope. Kepler-90I, a sizzling hot, rocky planet that orbits its star every 14.4 days, was discovered using Google machine learning. With the discovery of an 8th planet, the Kepler-90 system becomes the first to tie our solar system for the number of planets. Kepler-90, like our solar system, has rocky planets near its sun-like star, with gas giants orbiting farther away. Kepler-90 is more than 2,000 light-years away, and none of its planets are considered suitable for life. As we predicted, there are exciting discoveries lurking in our archived Kepler data, waiting for the right tool or technology to unearth them, said Paul Hertz, director of NASA's Astrophysics Division in Washington. This finding demonstrates that our data will remain a treasure trove for innovative researchers for many years to come. The discovery was made after researchers Christopher Chalieu and Andrew Vanderberg trained a computer to identify exoplanets in Kepler light readings, which are the minute changes in brightness captured when a planet passes in front of or transits a star. Inspired by how neurons connect in the human brain, this artificial neural network sifted through Kepler data and discovered weak transit signals from a previously unknown eighth planet orbiting Kepler-90 in the constellation Draco. Machine learning has previously been used to search the Kepler database, and ongoing research shows that neural networks are a promising tool for detecting some of the weakest signals from distant worlds. Other planetary systems likely hold more promise for life than Kepler-90. Kepler-90I is approximately 30% larger than Earth and is so close to its star that its average surface temperature is thought to exceed 800 degrees Fahrenheit, which is comparable to Mercury. Its outermost planet, Kepler-90H, orbits the star at a similar distance as Earth does the Sun. The Kepler-90 star system resembles a miniature version of our solar system. Vanderberg, a NASA Sagan postdoctoral fellow and astronomer at the University of Texas at Austin, explained that there are small planets inside and large planets outside, but everything is much closer together. Xiaoyu, a senior software engineer at Google's research team Google AI, came up with the idea to use a neural network on Kepler data. He became interested in exoplanet discovery after learning that astronomy, like other branches of science, is rapidly becoming data-saturated as space data collection technology advances. In my spare time, I started Googling for finding exoplanets with large data sets and learned about the Kepler mission and the massive data set available, Xiaoyu explained. Machine learning shines in situations where there is so much data that humans cannot search for themselves. Kepler's 4-year dataset contains 35,000 possible planetary signals. The most promising signals in the data are verified using automated tests and, on occasion, human eyes. However, these methods frequently fail to detect the weakest signals. Xiaoyu and Vanderberg suspected that there might be more interesting exoplanet discoveries lurking in the dataset. They trained the neural network to identify transiting exoplanets using a set of 15,000 pre-vetted signals from the Kepler exoplanet catalog. On the test set, the neural network correctly identified true planets and false positives 96% of the time. After the neural network had learned to detect the pattern of a transiting exoplanet, the researchers used their model to search for weaker signals in 670 star systems with multiple known planets. They assumed that multiple planet systems would be the best places to look for new exoplanets. We got a lot of false positives for planets, but also potentially more real planets, Vanderberg explained. It's like sifting through rocks for jewels. If you have a finer sieve, you will catch more rocks, but you may also catch more jewels. This neural network sifted out more than just Kepler-90I. In the Kepler-80 system, they discovered a sixth planet. This one, the Earth-sized Kepler-80G, and 4 of its neighboring planets form a resonant chain, which is formed when planets are locked in a rhythmic orbital dance due to mutual gravity. The end result is an extremely stable system, similar to the 7 planets of the TRAPPIST-1 system. Kepler created an unprecedented dataset for exoplanet hunting. After 4 years of staring at one patch of space, the spacecraft went on an extended mission and was retired in 2018. These findings demonstrate the enduring value of Kepler's mission, said Jesse Dotson, Kepler's project scientist at NASA's Ames Research Center in California's Silicon Valley. New ways of looking at data, such as this early-stage study using machine learning algorithms, promise to yield significant advances in our understanding of planetary systems orbiting other stars. I'm sure there are more firsts in the data waiting for someone to discover them. NASA's Kepler Space Telescope was designed to measure the frequency of Earth-sized planets. These planets orbit sun-like stars, but their detection sensitivity is at the limit of the mission's capabilities. To accurately determine the occurrence rate of these planets, it is necessary to automatically assess the likelihood of individual candidates being planets, even with low signal-to-noise ratio. We present a method for classifying potential planet signals using deep learning, a machine learning algorithm that is now widely used for various tasks. Our deep convolutional neural network predicts whether a signal is a transiting exoplanet or a false positive due to astrophysical or instrumental phenomena. Kepler-90's planetary system consists of 2 giant planets, 3 Neptune-sized planets, and 2 terrestrial planets. Bottom. Comparison of the inner terrestrial and outer giant planets of the solar system. Planet formation in multiple stellar systems is influenced by interactions between companion stars and their disks. Tidal truncation in the circumstellar case causes protoplanetary disks to be smaller, fainter, and shorter-lived than those evolving in isolation, reducing the amount of material, gas, and dust available to assemble planetary embryos. In contrast, in the circumbinary case, reduced accretion can extend the disk's lifetime, which benefits planet formation. In this chapter, we review the main observational results on disks in multiple stellar systems and discuss their possible explanations, with a focus on recent numerical simulations that primarily deal with dust dynamics and disk evolution. NASA's exoplanet program consists of many different components, ranging from current ground-based telescopes and space-based observatories to future missions. NASA's Kepler Space Telescope detects a slight dip in a star's brightness caused by an exoplanet passing between Earth and the star. The collected data resembles the U-shaped pattern shown in the image. Kepler has detected over 30,000 signals from potential exoplanets. Using Google machine learning techniques, researchers analyzed Kepler data from 670 multi-planet systems and discovered 2 new alien worlds, Kepler-90 and Kepler-80g. The Kepler-90 system's 8 known planets are organized similarly to our solar system, with smaller planets closer to the star and larger planets farther away. The Kepler-90 system has 8 planets that are closer to the host star than Earth is to the Sun. Experts believe there could be more planets in the Kepler-90 system. The vast majority of known exoplanet systems contain only one confirmed world. Kepler-90I offers hope that more multi-planet systems will be discovered. When NASA's Kepler Space Telescope first launched in March 2009, there were only 326 known exoplanets. Kepler has discovered more than 2,500 of the approximately 3,500 exoplanets confirmed so far. A solar system with as many planets as our own has been discovered using NASA's Kepler Space Telescope and artificial intelligence, the U.S. Space Agency announced Thursday. Our solar system is now tied for the most planets orbiting a single star, NASA stated. However, none of the planets are expected to be suitable for life. The 8-planet system, the largest known outside of our own, orbits a star called Kepler-90 about 2,545 light-years away. Andrew Vanderberg, an astronomer at the University of Texas at Austin, described the Kepler-90 star system as a miniature version of our own solar system. You have small planets inside and large planets outside, but everything is squeezed in much closer. The newly discovered planet, Kepler-90I, is rocky like Earth, but orbits its star once every 14.4 days, so a full year there is equivalent to 2 weeks on Earth. Kepler-90I is not a place I'd like to visit, though, Vanderberg admitted. The surface is probably far too hot. NASA calculated its average temperature to be around 800 degrees Fahrenheit, 426 degrees Celsius, which is as hot as Mercury, the Sun's closest planet. Scientists discovered it using Google's machine learning technology. The process entailed teaching a computer to scan a trove of 35,000 possible planetary signals gathered from NASA's Kepler Space Telescope in search of signs of planetary transit. Transits are the dimming of light caused when planets pass in front of a star. The Kepler Space Telescope launched in 2009 and has scanned approximately 150,000 stars. Astronomers have already confirmed the existence of approximately 2,500 distant worlds using Kepler data. I became interested in applying neural networks to astronomy when I discovered that the Kepler mission had collected so much data that scientists couldn't examine it all manually, said Christopher Shalyu, a senior software engineer with Google's research team. Instead, scientists chose the strongest signals, which are more likely to be actual planets, to get the most attention. Shalyu compared the process to looking for a needle in a haystack. Machine learning shines when there is too much data for humans to examine on their own. More planets are expected to be discovered because researchers intend to apply their neural network to Kepler's entire database of over 150,000 stars. There is a lot of unexplored real estate in the Kepler-90 system, Vanderberg explained. It would almost surprise me if there weren't any more planets orbiting that star. One day, artificial intelligence may be used to specifically search for more Earth-like planets, which have proven difficult to identify. For the first time since our solar system's planets were discovered thousands of years ago, we know for certain that the solar system is not the only one with the most planets, and we have only scratched the surface, Vanderberg added. Perhaps there are systems with so many planets that our 8-planet solar system appears ordinary.